All right, let's jump right into it. This is your super quick 5-minute revision guide on measurement. We're going to break down everything you need to know into simple, easy to remember points. Let's get you propped. So, got a test on measurement coming up? Yeah, I get it. It can be a little stressful, but seriously, don't you worry. This whole explainer is designed to get you confident and ready by hitting all the key things you need to know. Okay, so here's the game plan. First, we'll nail down what measurement even is. Then, we'll talk about the universal language that scientists use everywhere. After that, we'll get into the how-to of measuring matter, talk about why being accurate is so important, and then we'll wrap it all up with a quick quiz to see what stuck. So, first up, what on earth is measurement? You know, it's something we do all the time, even when we don't think about it. Like when you're baking a cake and you need exactly 200 grams of flour, or you're figuring out how long it'll take to get to school. It's basically how we make sense of the physical world. And here's the secret, right? All measurement is just comparing things. When you measure a desk with a meter stick, you're just comparing the unknown length of the desk to the known standard length of the meter. That's it. It's a comparison. Now, this is a really key point in science. We have to know what we can measure and what we can't. We can measure physical quantities, things like length, mass, and time, but we can't really assign a scientific number to things like love or kindness. They're real for sure, but they're not physical quantities we can measure with a tool. Okay, but wait a second. If it's all about comparing to a known standard, how do we make sure my standard is the same as your standard? Or a scientist in Japan? How can they share their results with someone in Brazil and know they're talking about the exact same thing? Well, they need a common language. And that shared language is the SI system. Think of it as the universal translator for science. It's this global standard that makes sure a kilogram in a lab in Canada is the exact same as a kilogram in a lab in Australia. It makes science work everywhere. And these are the big ones, the core SI units you'll see all the time. For length, we use the meter. For mass, the kilogram. For time, the second. And for temperature, in science, we usually use Kelvin. These are like the fundamental building blocks for pretty much every other measurement out there. All right, enough theory. How do we actually do this stuff? Let's get our hands dirty, so to speak, and look at the real tools and tricks for measuring the world around us. I mean, it's pretty obvious, right? For every measurement, you need the right tool for the job. You wouldn't try to measure time with a ruler, would you? Of course not. Using the correct instrument, like a balance for mass or a stopwatch for time, is always step one. Okay, let's talk volume. That's just the amount of space something takes up. Now, for a nice, regular shape like a cardboard box, it's super easy. You just measure the length, width, and height and multiply them together. But what about something lumpy, like a weird-shaped rock? You can't just measure its sides. For that, we've got a super clever trick up our sleeve called the water displacement method. You just take a measuring cylinder with some water in it, note the starting volume, and then gently drop your object in. The water level will rise, right? The amount it rises is the volume of your object. Pretty cool, huh? Now, once you know an object's mass and its volume, you can figure out its density. Density is just a way of saying how much stuff is packed into a space. A bowling ball and a beach ball might be the same size, have the same volume, but the bowling ball has way more stuff packed inside. It's more dense, and you find it by just dividing the mass by the volume. So we know how to measure things, but that's really only half the story. Getting a number is one thing, but can you trust that number? This is where accuracy comes in, and it's absolutely crucial. Okay, here's a pro tip to avoid one of the most common mistakes out there. It's called parallax error. It happens when you look at a scale, like on a measuring cylinder, from an angle instead of straight on. It can totally throw off your reading. The fix is so simple. Just get down to eye level with the measurement, every single time. And don't just take my word for it. Researchers have found that one of the best ways to think about good measurement is to think about trustworthiness. Are your results trustworthy? In science, your measurements are your evidence. And if your evidence isn't trustworthy, well, your conclusions won't be either. Okay, you've been listening, you've been learning. Now it's time for a little knowledge check. Let's see what you've got. You ready? First question. Let's talk about mass. That's the amount of stuff in an object. What is the standard official SI unit we use to measure it? Yes, if you said kilogram or kg, you are absolutely right. Well done. All right, round two. Think back to the lab. A graduated cylinder is used to measure the blank of liquids. What's that missing word? Volume. You got it. Exactly right. Graduated cylinders are perfect for measuring the volume of liquids and for finding the volume of those irregular solids too. Awesome job. So let's do a super quick recap. Remember, measurement is just a comparison. We use SI units so that it's the same comparison for everyone, everywhere. We can find volume with a formula or that cool water displacement trick. Density is just mass divided by volume. And please, please always read your instruments at eye level to keep your results trustworthy. And I want to leave you with this one last kind of cool thought. We used to define a kilogram by an actual physical chunk of metal sitting in France. Now we define it using universal constants of nature, like the speed of light, things that never ever change. It just makes you wonder, as our tools get better, what new things will we be able to measure next? Great job today.